Guy Schumann. He is going to talk about the value of drones for bespoke local flood risk assessment in the Licungo Basin. He's with the United Nations World Food Program and has master's and PhD degrees in remote sensing and geography from the University of Dundee. He's worked at the University of Bristol as a research fellow and professor. And then he joined NASA's JPL and Caltech, where he worked on the upcoming NASA SWOT hydrology satellite mission. And then in 2015, he started research and development work on NASA-funded projects in the private sector by joining RSS. And he's now active in the R&D sector, both the US and Europe, and has affiliations both in the University of Bristol and University of Colorado Boulder. Sorry about that. He's also a scientific advisor to the UN World Food Program. And his work focuses on large and fine-scale flood inundation modeling and integration with remote sense data that is geared towards interoperability of products to assist in flood disaster response. Welcome, Guy.
Thank you, Anna. That's and great to be here. Thank you, everybody, for inviting me. So I'm glad actually to do this online. I do say this very rarely nowadays. You know, everything is online, but this is actually GFP is actually a structure I like online. 4 weeks. This is the last one. Very good. So I try to speed it up a little so we have more time for general discussion, and then the speaker after me can also have time for his talk. So bear with me when I try to share my screen. I hope everybody can see the presentation as well as hear me and see me.
Perfect, Guy. Thank you.
Okay, thank you. Thank you, Albert. Again, thank Anna for introducing me so nicely. That's great. Thank you. So I'm here. This is the first time actually I do this, and I don't feel right to do so because I'm just, advising the WFP. So on some days a week on a lot of flood disasters. So here I actually try to present a project that they have initiated with the National Disaster Management Agency in Mozambique. And I've been part of it just a little bit doing, helping out with the modeling, etc. So I don't feel at ease to do it. I do my best, but hopefully if there are questions, you can also get your questions to Michael Manalili or myself actually would try to answer. So I'll talk to you today about some very big, I think personally, innovation project that uses drones for bespoke local flood risk assessment in a basin in Mozambique. So let me get started with a little bit of background. So INGC, as I just said, is the National Disaster Management Institute in Mozambique, and I don't dare pronounce it out in Portuguese, but I say Portuguese because later on you see that language can be a barrier and it's very important for local community work. So they have a partnership with WFP, of course, with the country office of WFP over in Mozambique, Maputo, to look at projects that would help them do disaster response locally and at government level better using newest geospatial technologies, or even like here, unmanned aerial systems or UAVs or drones, as we like to call them. So how do you actually get this done? You need high performance computers, you need a drone fleet, you need personnel that's trained. You get the big data. Everybody talks about big data, but how do you then analyze, extract useful information that could be used to respond to flood disasters at the very local level, at town level or village level? So again, some background here. So Michael, who I work with a lot, at Michael Manalili at WFP in Rome, had actually a 3 weeks field support to the Maputo country office of WFP. there the idea was to work on a drone project and to look at a past flood event to see how we could respond to that using newest drone acquisitions to build digital elevation models, have photos available for more asset recognitions and exposure mapping. And this was all funded by the European Civil Protection and Humanitarian Operations called ECHO. And of course, in partnership with the Mozambican government and INGC. So the purpose was actually very easy. It was to see if, how would you increase preparedness with the data analysis collected from a drone? They were very interested, the government was very interested in using drones to see what else they can do at local level. Of course, Mozambique is a huge country, and every basin is very much prone to flooding, to a lot of flooding, and a lot of flooding regularly. So it's not something you can easily do. This is just an example of one basin in blue. The outline is in blue. And hopefully you see all the little airplanes that actually tell you where their drone were flying. And some numbers here for anybody that has done some drone flights. One flight on a drone takes 20 minutes max because of battery lifetime or duration, let's say. So 20 minutes max, one flight, and you can maybe do half a kilometer squared if you're lucky. So look at these numbers. They did 235 drone flight missions, 58 hours of flight time, and almost 160 square kilometers of area covered. Now, if you put that in context to my country where I currently sit in Luxembourg, that is a big area for us. But if you look at the map of Mozambique of just one, the Licungo River Basin is a very small area they managed to get. If you look at all the rivers there, if you can see them. So that's over 0.5 terabyte of data. How do you get this to the people actually needing to process the data? So all of these are big challenges. Almost 300,000 aerial photos and 12 people with 4 teams doing the drone. I don't think that's a lot of people, by the way, but given the flight missions. So they did a great job. And very often when you have these drone flights, you would have ground control points and with very good GPS measurements. Here, that wasn't really possible for most of the time. So again, another challenge. So here's just a photo to show to you that it's real. These are the people that got trained by WFP and a drone service provider to tell them how to do mission planning. So all were very happy, took it very seriously, and ended up with actually some very nice data, I think. So first of all, with all these photos and photogrammetry of processing, we could actually do a digital elevation model. So that's what they did for us. But then the big question they had was, what can we all do with this data? And actually to respond to disasters locally, it's a very good question. So if you then take the example of what we have currently available in Mozambique or in any other country, you could go for global flood model. As we know, a lot of providers have access to them now. JRC have the European Joint Research Center in Italy have a global hazard model. Typically, they all have more or less the same processes. They represent more or less the same processes. They lack some quality data like the DEM in some places. They lack flood defenses maybe. They lack dams. They may, but they are very good for certain things. They're very good to give you regional awareness, regional hazard assessment, regional risk assessment. If you have high quality data, like in the US, for instance, they may be able to provide you with very high, even detailed local assessments. But here in Mozambique, where there's typically not a regional digital elevation model available that of high quality, there's not easily accessible high quality discharge or rainfall available. So there you have a global model that is not really doing great at local level. So just to show you the area where we actually worked with the drone and had a local town completely flooded in 2015, that global model here doesn't pick up much other than the big river running through it. So this is the thing. And actually we then thought, well, was the 2015 event so big? And actually you see the relief web report with the photo there. It was actually massive. It ripped away most of the houses. It's a small town, but I would say pretty much in the wrong location for natural flood processes. You know, it's right on the edge of a big river, low-lying floodplain, the typical scenario, and then fishing town. So you can imagine what happens during a big flood event. Here also the GFTR report. You know, a lot of people got killed in that basin, and it actually cost Mozambique a lot of money. So here we are with our drone-based DEM for this particular town called Mokuba. So the spacing of the pixel is absolutely marvelous. If you think that the only DEM so far available was probably SRTM, 90-meter resolution, few meter in the vertical accuracy. Here, you then go from that DEM to a 40 centimeter per pixel and half a meter in the vertical accuracy. So you completely change the game in that sense. But luckily, working with national government and local communities, they actually tell you that there's a gauge that measures the discharge in a river that most people doing global flood modeling wouldn't even have heard about. So that enabled us to build a fairly standard, I would say, 2D flood inundation model. You have discharge, you have a downstream controlling boundary. You set it up over this very small domain size, but very high resolution. And you see what you can do in the flood model. So the great thing is, because it's observed discharge and a relatively good DEM, the model actually doesn't do too badly. So that's what you can do with the DEM and looking at flood modeling. So here's something else you can do. If you get all these photos that generate the DEM, you can also use these photos to look at asset exposure. So basically map buildings, map roads, and you can share that then to let's say to other platforms, or open aerial map, for instance, is something like OpenStreetMap for for aerial mapping essentially. So you can also start validating the famous Facebook high resolution data for Africa in that location, because you get something higher resolution now that the satellite data that Facebook used. So you can do all this, but then some people may wonder, I myself wonder, why don't you use OpenStreetMap to look at these things? Well, let me skip this slide, I'll come back to it later. So here, for instance, great example, 2014, before the big flood event in 2015, OpenStreetMap, no data. No data on where a building was, no data on where roads are, nothing. So that means after the 2015 event that the humanitarian community started mapping from commercial satellite images to put it into OpenStreetMap. So now if you go to OpenStreetMap, you actually find the buildings and other assets in that database. And that's very, very common in many countries around the world, where we all believe that Google or OpenStreetMap project have mapped everything. They have mapped really just a little percentage of what's out there. So humanitarian communities very often, like also, Doctors Without Borders and WFP, they start these projects where they map assets on commercial satellite images from Maxa, for instance, and feed it then to OSM. So great. So now we have this data available from OSM, but is it really any good? So we compared it to our drone image. We see that some is missing, but in general, it's really good. So that's also one thing to use the drone for. You can actually check whether the data you have in these freely available sources is actually true, or whether you have more buildings that were added more recently, etc. So you can augment your, let's say, your exposure data. So if we overlay that then with the drone-based DEM and our model, we can start seeing why this is useful. For instance, in this flooded situation, at some time step in the 2015 event, you can see that some buildings already start to be covered by water. And this is not even looking at the peak. So going back now, so if you see, okay, let's take the maximum flood extent of the 2015 event based on the modeling and use that exposure data, you can really do some nice numbers here. And you can very quickly see how disastrous that event is. And bear in mind, if on the global model, you would probably see just a few pixels within the river channel, nothing else, no flooding happening there. But as these global models also improve, you may see more similar pattern to the drone here, to the drone-based model we use here. And you may also have noticed that in the drone DM, that bridge is totally gone. And that is because in the 2015 event, that was totally gone. So another way to do it would be first to reconstruct that bridge, then to see if the model also, goes, around that bridge or what happens to the flooding. But here we didn't have that. So we just, assumed, okay, let's run the model anyway, see how well it does. And the thing is, with these statistical analysis, like counting the buildings that are flooded, you don't really know how well you're doing. But you can, of course, put it on online platforms to look at, like basically risk. So color it with a risk-based index where you say, okay, this is, what is the number of structures? How are they exposed, given the different time steps of flooding you see in the model? So the WFP shared that on different databases within the humanitarian community. So then there was the big question more from my side is how do we even know this model is doing anything correctly, right? We're assuming it's a good DM. We're assuming it's a good discharge data that we feed in the model, but how do we know it's good? We can use here Digital Global. I should apologize. This should say MEXA for now. So high resolution reference image, we used it. Luckily, a bit cloud free. You see the same pattern of the river channel that you saw in the model. And we put a few pins there just to see, okay, do we actually flood these areas as well in the model? And luckily enough, we did. But as I said, it's a large event. So it's very easy to say, well, yeah, that's natural. It floods easily in the model. Then you can do something that is typically also done in most models that are developed in countries like where the quality is high, of data is high, and you can get some event pictures, let's call them, either from local community or government officials that were there, took a picture, and you can see, okay, in the picture it's difficult to recognize where it was, but that was definitely the bridge that's now gone. So, I mean, not too bad that there's a lot of water there. That's all you can say, essentially, that there's a lot of water also on the floodplain. You can see some buildings are destroyed. So the model is probably inundating correctly. One other thing you can do, and actually I think this is the greatest thing I have ever seen in any flood modeling exercise, is that we decided why not do a small survey, easy survey, 5 questions in Portuguese to the community that got flooded and spread that around as much as possible to get a lot of responses from the local people. So individuals whose houses they actually were that got flooded or destroyed. First question, and you can see it's in Portuguese. I try to translate as best as I can. So first of all, number of residents in that building, how deep was the inundation? So this is a very tricky question because obviously we don't want locals to come back to us and guess at centimeter level how high the water was standing. It's very difficult to do even for an expert to say, okay, this is like 80 centimeters or maybe it's 90, I don't know. So we just went with the human body and categorized it. So we asked the people, was it above your head as an adult? Was it at your chest height? Was it at your waist height? Or was it at your knee height or ankle height? Or, also was it above an average height kid or, a toddler? These kind of questions, very easy to answer. So this person, for example, here, where you see the cyan square around the house, said that his house was, he was flooded above the head. It means in Portuguese, I hope so. So we were thinking, well, this may be 2 meters or not. Are we sure this is right or not? We cannot be very sure, but hey, they uploaded photos as well. So yes, we can be sure because as you see on the photo, his house is totally gone. So it must have been at least what he was saying, or at least let's put it this way, it's not unimaginable that what he did say is correct. The house is gone. So we have about a couple of hundreds of these points in different locations, as you see here. And again, we see our model does not too bad, but actually having these number of spatially distributed data points and from individuals reporting numbers or text, but it's more or less convertible to numbers with an uncertainty, let's say, of more or less 10 centimeters, you can see that actually the model has also in some places a hard time to match this. And this is very typical. It's not that we expect models to do great with great data if you start having this kind of spatial distributed data. But remember, this is a town that's very often completely omitted from global flood models, also from relief services, because it's not showing up on a satellite image either. It's very cloudy. It's in the middle of complex terrain. The river is relatively small to be captured well by a 30-meter Sentinel satellite image, for instance. So, but here you have a community that is in serious trouble, and they tell you that actually, we give you data if you want data, but then we have trouble matching it with the model in some places. Here's another example of what we've done. So here's the person that worked with us from INGC. He gave us real-time readings from the gauge, and we ran the model, and we could actually start validating it real time to see if his water level readings that he has actually make sense or are in line with what the model shows. So this is via WhatsApp, of course. By the way, WhatsApp, I think, is one of the more widely used, if you like, mobile device apps in these parts of the world, because mobile phones do actually work in contrary to Wi-Fi networks, for example, which very often don't work. So mobile networks is not too bad at all. And that's what we did. So going back and asking ourselves, so what else can we do? I mean, malaria is a problem in these regions. So could we do something like with this DM and the model to look at mosquito breeding regions? And fair enough, yes, we can, because if you are left with areas that are not drained perfectly in the model due to rainfall, you can assume that that would be an ideal breeding ground for mosquitoes. So that's something we could do, more of an innovative use, I would say. And so this is how we did it, a simple GIS exercise, essentially looking at what water is left in the low-lying areas and doesn't drain back to the channel. It basically is a desired spot by mosquitoes for breeding. So something else we did with the, I think it's the WFP team for artificial intelligence. They start using these imagery from the drone for counting humans, essentially, seeing humans in images, recognizing them and seeing if they are in need of rescue. So that's something else you can do with, combining the drone data with artificial intelligence. So there's a lot of innovation possible if you start having these drone data at very local areas. And we presented, of course, the results were presented, let's say, at national level with senior people, also representative from Brussels, WFP Rome, and INGC, ECHO representatives, so all the guys supporting this project, and also the local community. And there was even a poster conference as we know it, showing what's possible. And so essentially, I think that's more or less my talk. And I just want to say a few things at the end, that because they now see the value of this, they of course are very eager and over-ambitious. They now want to do it for the whole of the province, if possible, all of Mozambique. But of course, with a drone, that's a bit of an over-ambitious project, to say the least. So we need to see how we can scale what we've shown here to make it possible for other regions in the country. And there's a lot of work going on also with the Red Cross in this respect. And even ESA is very interested in running an InCure program to look at the drone data that was used there to see how can we use it for better flood mapping in Sentinel-2 images. So yeah, that's it from me. I mean, if there are any questions, please feel free to put them in the chat. I haven't had a look yet, but I will and try to respond to them as best as I can. If not, get back to me by email and I try to answer. And if I can't, I will forward them on to WFP or INGC. Thank you.